In the foundry, Adolph's anti-shift inserts are guaranteed to solve your alignment problems. They do so more quickly and accurately than any other method. After a lifetime of solving difficult lineup problems, Adolph Volkmann has incorporated his experience into a simple yet ingenious design, sure to become the industry standard. Anti-shift inserts are made from a high-grade plastic and come in matched cope and drag sets. The practical advantages of anti-shift inserts can best be explained by a foundryman who uses them every day.
Durmetal Corporation is a manufacturer of wear products, brake drums, and commercial castings for heavy industrial use. We have two types of molding processes, the V process and a no-bake molding system. And we went into our V process molding area, which is a 34 by 60 mold weighing approximately 3,000 pounds. At that time, we felt an anti-shift of a 3 to 4 inch size was more appropriate for that size of mold. Prior to using Adolph's anti-shift inserts, we used a shell core lineup. We bought that as an outside consumable. We had handling involved with that. We had shift problems in our castings. Once we switched over to the new style inserts, we eliminated those costs associated. We created a better product, and we saved money and put us in a more favorable competitive position in the marketplace.
Anti-shift inserts are available in Style A and Style B. First, we'll demonstrate Style A. Drill pilot holes all the way through the matchboard. Then, using a flat bottom cutter or our specially designed fly cutter holder, it is recommended that the hole be drilled slightly deeper than the depth of the female insert. It is helpful to use a spacer that matches the depth of the female insert. Then gradually raise the table until the cutter slightly breaks the surface of the matchboard. This is necessary to ensure that the counterboard hole will be deeper than the depth of the insert. Remove the spacer and drill the counterbore. Whatever method is used, the counterbore should be slightly deeper than the depth of the insert. Notice how we have placed the matchboard on two parallel support boards to ensure that the matchboard will be level and that the holes will be perpendicular to the matchboard. After being installed, the mounting rim will always keep the insert at the proper depth. Once all the holes have been drilled and counterbored, simply place the male insert in the pilot hole opposite the female insert and secure with a number 12 wood screw. This demonstrates how easily anti-shift inserts are installed on existing pattern equipment. The mounting rim serves two purposes. It always keeps the inserts at the proper depth when installing, and it serves as a sand trap when closing the mold. This animation shows how anti-shift inserts work in the molds. When the matchboard is removed, the impressions in the mold sand guarantee perfect alignment. Any loose sand that would hold up the parting line is trapped. With the Style A anti-shift inserts installed on the matchboard, let's take a look at how they function in creating the mold at the foundry. Anti-shift inserts can be used with green sand, air set, cold molding, molding boxes, vacuum molding, or match plates, and for core alignment. This is a completed cope mold in green sand and shows the alignment button with the sand trap created by the mounting rim. Here is the drag mold with the matching cavities created by the anti-shift inserts. These cavities align perfectly with the buttons created by the cope mold. The buttons created by the anti-shift inserts guarantee constant mold alignment will be maintained when the snap flasks are removed. Also, during subsequent movement, transport, or further handling. After the casting is completed and removed from the mold, the advantages of using the anti-shift inserts are clear. Now, we will examine the difference between castings created by anti-shift inserts and other lineup methods. The mold for this casting has maintained perfect alignment because of anti-shift inserts. And this is the kind of scrap that is eliminated because you get a perfect match every time. For separate cope and drag boards, first drill pilot holes all the way through the cope board. Then adjust the table to drill the matching holes only 3/8 inch deep into the drag board. Now match the boards face to face and secure with clamps. Style A inserts are specifically designed for thicker matchboards, molding boxes, or to be mounted separately from each other on cope and drag boards. Drill the 3/8 inch deep matching holes in the drag. Then counterbore the cope to a depth slightly more than the insert as previously demonstrated. Simply press the female insert into the counterbored hole and secure from the back side with a washer and wood screw. To complete the installation on separate cope and drag boards, simply twist the male insert into the drag board and secure firmly with a number 12 wood screw. The anti-shift inserts are now completely installed on the cope and drag boards. This method also works equally well with molding boxes. And here is an example that will be used in airset tooling. This is the airset mold with the buttons and cavities created by the anti-shift inserts. A closer examination of the button shows how the sand trap holds any particles that may interfere with closing at the parting line. It is crucial that the cope and drag be matched with proper alignment and allowed to harden together. Anti-shift inserts guarantee proper alignment and eliminate the need for lineup cores and the handling they require. The animation shows how Style A cope and drag inserts mounted separately align in a single mold. When the cope board is only slightly thicker than the depth of the insert, drill 4 relief holes in the counter bore hole. Apply plastic glue, such as Bondo, around the edge and bottom of the insert, as well as the sides of the hole. Firmly press the insert into the hole and any excess Bondo will escape through the relief holes. Remove any excess and sand off the end of the insert. This is how the properly installed insert should look. This concludes our demonstration of Style A. To install Style B on an existing matchboard, locate the inserts away from the pattern. Drill pilot holes all the way through the board as we did with Style A. Then, as a very important safety precaution, counterbore a hole only halfway into the board. It is very dangerous to counterbore a hole all the way through from one side. Turn the board over, align the cutter with the pilot hole, and finish drilling the hole from the opposite side until the two cuts meet. This maintains a pilot chip in the center that keeps the cutter centered. The cutter must never exit the bottom of the board. This would be very dangerous. One of the outstanding features of Style B inserts is that they are very quickly and easily installed on all pattern equipment. Remove the pilot chips and snap the two halves of Style B inserts into place and fasten together with a number 12 wood screw. Style B inserts are made of tough, non-sticking, and acid-resistant plastic. They were especially designed for match plates, match boards, and automatic molding machines. The most suitable screw to use is a number 12 Phillips type pan head screw for the installation. Style B inserts can be mounted from the cope or drag side. It makes no difference, because the mounting rim in each half creates a sand trap on both sides of the parting line. On match plate applications, the process is the same. You can see how much play is inherent in using pins alone for mold alignment. Drill proper sized holes in the match plate. This requires specialized tools. After the holes are drilled, snap the two parts of the insert together and secure. There is no other way to create a matching button 1 inch deep on a 3/8 or 1/2 inch thick match plate other than Adolph's patented method. Style B inserts are unique in that they telescope to match the thickness of the matchboard or match plate. The only thing that needs to be adjusted is the length of the screw. They may be mounted on existing matchboards and match plates with a minimum of effort. They are also extremely durable and resistant to acid, chemicals, and industrial solvents. They are also reusable. For specialized applications, Style B machined aluminum inserts are also available. Because they have zero tolerance in the diameter, these are for green sand molding only. There are a number of advantages to using Antishift inserts. Here, Style A inserts are installed in molding boxes, eliminating the need for any kind of outside alignment box. The shape of the mold can closely follow the shape of the pattern, reducing the amount of mold sand needed and reducing waste. They are also perfectly suited for unusual mold applications, where traditional alignment methods would be difficult and costly. Now you have seen the advantages of using Antishift inserts, how they work in molds, and how easy they are to install. Imagine the savings you could realize by using them to solve your lineup problems. Let's check back with Dave Sutter. Dave, are Antishift inserts an indispensable part of your production process?
Yes, one of our largest scrap problems in the past was for shift. Because of our no-bake molding system, we rely on our anti-shift inserts to line the mold up, whereas in the old foundry practices, you closed on pins, steel pins. Well, with the no-bake system, we don't have those anymore, so we rely on the anti-shift inserts for 100% of the alignment.
To provide the perfect alignment solution, Style A comes in 4 sizes and 3 depths, while Style B comes in 3 sizes and 2 depths. The specially designed fly cutter with interchangeable wood cutting blades makes installation easy. Both the inserts and the wood cutting tools are unconditionally guaranteed. The people of Oregon have long been known as pioneers, and Antishift inserts are an important new innovation in the pattern making and foundry industry. So when you are looking for a new way to solve your alignment problems, remember that someone has already blazed a new trail, and call Adolph's Pattern Shop at 503-253-0602. Don't be left behind.